Good morning, good morning, good morning. All right, let's talk about some of these word problems. Okay, so if you have other friends that are taking CP Algebra 1, we skipped one section, which we'll go back to on Friday. We're like a day ahead of them on the word problems, but they had this other thing. Don't you worry. We have scheduled 1 week from today our test on this unit. So I want to make sure we feel good about it. But the hard thing about word problems is they're word problems, for crying out loud. And sometimes they're a little tougher, okay? Because they're tough because your confidence of trying to say, wow, I have to actually make an equation out of a story is a harder thing to do. So let's, Kieran, your first name up here, so you're going to the back, okay? Brennan's there. All right, so Tristan, I wanted to go through this whole worksheet. I know I only asked y'all to do a portion of them, the odds or the evens, I can't remember, but I want to just start with number 1. Is that okay?
Sure.
And we're just going to kind of make our way through this, see how we feel about it, but I really want us all dialed into it. So if you have your packet, that'd be great. Get it out. Let's go through it. If you don't, get out a sheet of paper, and we'll figure out how to go through it. But, so, Tristan, it says here on problem number 1, it says, suppose the length of a rectangle is 3 more than twice its width. The perimeter of the rectangle is 48 centimeters, and find the dimensions. So this is, again, this problem number 1. It's talking about a rectangle. So what might be an okay start to this problem without really going much further than the first couple of words? What do you think, Tristan? Problem number 1.
I would put L equals.
What is he? I'm sorry?
I would put L equals 2W plus 3.
Okay, so you're seeing that the length and width have something to do with it. But before that, I'm sorry?
It says that suppose the rectangle is 3 centimeters more than twice its width.
Okay, so we definitely know that we have a length and we have a width. I agree. And I agree that they have some sort of relationship. But I think even before that, what might be an okay place to start where some people might see it and some people might not? What would be, and I know that Christian has the sarcastic answer, but we're not going to go with his sarcastic answer because I like it, but I don't like it. What should I do? Yeah, make a rectangle. Just make a rectangle. And again, we're all indoctrinated to know that the rectangle's length is longer than the width. And again, there's no reason why they had that other than elementary school teachers thought it was good for you to remember because length had long and the same thing, and you're getting onto your thought process of these. But then they give you some information. Anytime I'm talking about a rectangle, I think it would be a good thing to write down the area equation. Tristan, what's the area of a rectangle as in relation with length and width?
2L plus 2W.
I agree with that with perimeter. What's the area one, though? What do you got? Yeah, length times width. L times W. Okay. So those are the 2 equations I know just kind of in my little packet of equations that we've come across for so many years. I know that. So will I necessarily use both equations? Probably not, but it's nice just to kind of have them off to the side, know that I could refer to them if I need to. But let's see what this problem says. So Ray, I'm coming to you. It says that the length of the rectangle is 3 centimeters more than the width. So Ray, the length is equal to what? How would it? W plus 3? Okay, hang on. Suppose the length of a rectangle is 3 more than twice its width. So I'm almost there. So what's the last thing I should put? 2 in front of the W. So we're going to double the width and add 3 to it. Okay? So here's the nice thing. I know that the length, this, is the same thing as 2W plus 3. And then I know I have W here. Okay? What other information is this problem going to give us? Total what? What's total 48?
Total perimeter.
Okay, so the perimeter, using this equation, I know that perimeter is equal to 48, is it centimeters, meters, yards? Centimeters? Okay? So I know that. Sophia. So being I know that my perimeter is 48, and I found the relationship of length is 2w plus 3, and the width, I'm just going to keep w. Is there a way that I could utilize this equation here with this information here, and that information there? What do you think? Okay. Substitution, yeah, you're just plugging in what you know. So I know that P is 48. They told us that. So I'm going to put 48 in for our P value. And then I have 2 times the length. Well, what do I know the length? Because of the story. 2w plus 3, I like it. And the width, I just know is w. And by me doing this, I've converted L and W into just w's. So now I have a single equation that I can use. So if we go through and utilize the math, let me go through this a little quicker. So I now know my width is 7 centimeters. So if I know my width is 7 centimeters, Casey, how am I going to figure out my length? Yeah. So they told us that we know that the length happens to be double the width and add 3 to it. So if I know that to be 7, I'm going to go length is 2 times 7 plus 3. 2 times 7 is 14 plus 3. So my length is going to be 17 centimeters. So I have a rectangle of 17 centimeters for my length, and I have a rectangle in which my width is 7 centimeters. Okay, so it's a matter of just kind of going through. But I think good practices, and it's not always for everybody, is list a couple of your equations that are go-tos. They are knowns because you've seen them over and over and over again. Okay, it doesn't take a whole lot of really deep thought to generate the area of a rectangle and the perimeter of a rectangle as far as the equations go. We okay so far? May I move on? So then number 2, can I clear that? Well, I'm going to go through all of them. So even though you didn't do all of them, we're just going to go through them all. Cool? What's that? Nope. We're going to do them in class. Is that all right? All right. So, Ben, we're going to talk about number 2. It says the length of the rectangle is 4 inches more than the width. The perimeter of the rectangle is 30 inches. What is the length of the rectangle? So, again, problem number 2, I think a good place to start would be my 2 equations. So, the area is what? Okay, and then the perimeter is also?
2 length plus 2.
There you go. Okay, so, again, I might not need both those equations, but I have them in the back of my mind. I might write them off to the side and just see what we can plug in. So, really, up here, I have 4 different variables. I have area, length, width. I have length and width, and I have perimeter. So, A, P, L, and W are all my variables that I need to solve. And another thing might be, if I draw the rectangle and label it length and width, and again, we've been told over and over and over again by our elementary school teachers that length is longer than width, and you later find out that it really isn't, and then you feel let down and that, Mrs. Patterson might have goofed you up in life. Like, who's Mrs. Patterson? She was my 4th grade math teacher or elementary school teacher. She wasn't the nicest person. But a kid did barf in class one time, and it was kind of funny. Earl Langlois, it was awesome. Yeah. Always remember, Earl was like, I don't feel so good. And she goes, what is it? He goes, bleh, and barfed. It was great. I don't know. I thought it was funny. And y'all are going back and thinking about the kid that barfed when you were in school. Perhaps that was you. I don't know. All right. So, Ben, it says the length of a rectangle is, what do we know? So the length of the rectangle is what?
4 inches
more. 4 inches more than the, okay? So we don't have to double the width because they just tell us that the length has to be 4 inches more than the width. And so now that I know that my length is 4 plus W, I can change that to 4 plus W. What else? What other information did they give us in there, Ben?
The perimeter of the rectangle is 30 inches.
perimeter is equal to 30 inches. Okay? So, am I going to use the area equation on this or the perimeter equation? Perimeter. Gabe, coming to you. Okay, so if I'm going to use the perimeter equation, you still following us in this adventure? And I know that the length is 4 plus W, and I know that W is just W. What can I do in order to start solving for our rectangle? Oh, I see what you're doing. So you've already distributed. You're absolutely right. So you're plugging in here. We already know this. We're plugging in here, right? So 2L. I know that L is 4 plus W, and I'm just trying to backpedal a step. And then I know I have 2W. And you had said if you distribute here, I think this was what you were saying. Do you agree with that so far? And then I have some like terms, so 2W and 2W. So I have 30 is equal to 8 plus 4W. Subtract 8. Is that 22? Ew. So that becomes 5 and 1/2, so that's 5.5. So my width is 5.5. Can I have a width that is a decimal? Yeah. So if my width is 5.5 inches, what would my length have to be? 9.5. I like it. 9.5 inches. So that's the dimensions in my rectangle. Now, things I could also find, if they wanted us to go one step further, we could technically find the area of this rectangle. I know it didn't answer the problem, but if I wanted to find the area of this rectangle, what should I do? What do you think, Bo? Length times width, yeah. So we could have it as an extension problem where they could give you the given information and they could say, hey, what's the area? Which that becomes a little bit higher level thinking because you're applying what is found to a new equation, which could be a known equation, such as area is equal to length times width. Cool. I like it. Andrew, coming to you next. Oops, no. Good capture. Good. Saving ink notes. Love it. We got good stuff. So, Andrew, our next problem is the length of a rectangle of a garden is 3 yards more than 4 times its width. The perimeter of the garden is 36 yards. What is the width and length of the garden? I like it. All right, let's get out of here. This, no. So, Andrew, another rectangle problem. Andrew, I know area is equal to length times width. We've only done it 3 times so far. And I know the perimeter is equal to 2L plus 2W. Okay? Andrew, talk to me about number 3. What are a few things that we know so far? Perimeter is equal to 36 yards. Okay, I like it. What else do we know? What? I'm saying, say that one more time. So the length is 3 more yards than 4 times the width. Sweet. So what can I do with this in relationship to my picture? Almost. Don't forget. 3 plus 4W. So my length is 3 plus 4W. And then I have W here. And by us doing that, Andrew, that allows us to go to one unknown, meaning one letter that we need to solve versus 2. Okay? Excuse me. Ashley, where should I go from here?
I kind of did it a different way than what you were showing.
Okay.
So I drew the rectangle and
Yep.
then on the top I wrote what you wrote.
Uh-huh.
But then I added all of the W's. So I wrote an equation. So I wrote 10W, and then since it said it was 3 yards, I put plus 3, and then I added 2 3s, which is 6, and then the perimeter was equals 36.
I understand exactly what you're doing.
I subtracted the 6 and 36, and then I got 10W equals 30, and then I divided by 10, and I got the width was 3.
Okay. That's a great thought process. I love it. Let me see. So you're saying you got W is 3?
Yeah.
Okay. So I'm gonna keep that in mind. I'm gonna underline that, knowing that's where I'm going to. Okay. So I think if I did this, if I do this and this and this, I'm gonna plug into this. So I have 36 equals 2L, which is this, and then 2W. And I think that I heard you saying all of this. And you know, your brain worked in a certain way that got you to. I think we're gonna have the same answer. That's gonna be a plus sign. 10W. That's 30. W equals 3. Okay, and you said that the width is also 3. Sweet.
And then I just plugged it in.
And you plug it back in. So I have a width of 3 and a length of 15. Is that right? Yes. And they're both in yards. 3 yards. So, cool. Your thought process got us the same spot. Your brain worked in that way to problem solve. And that's a pretty cool thing. Okay? And you know what was frustrating when I was a kid? I always hated when, no, you have to do it this way. And it's like, but my brain's not wrapping around that way. And there was a while in there that I thought that something functionally in my head was wrong because I wasn't thinking the same way the teacher was. But the beautiful thing is, your thought process got us the same results. And that's right. I like it. Keep it up. Huh? You hurting yourself?
Yeah.
All right. Clearing. Number 4. We're doing so well on this. I love this. This is great stuff. And I'm not fearing these word problems as much as I did earlier. I mean, I kind of cried myself to sleep a little bit last night because of it, but I think it'll be all right. You didn't sleep at all?
No.
Good.
So, 3, the answer for L is 15.
Yeah.
Because if you have 2,
Yes.
put in 3.
Yes.
4,
Yeah.
and then, all right.
Cool. All right. Angelo, coming to you. Yay. Here we go. Oh, wait a minute. Watch the language. You used it correctly, but watch the language. Number 4 says 8 times a smaller number plus 3 times a larger number is 28. Whoa. Okay. The larger number is twice the smaller number. Find the numbers. Oh my gosh. Angelo, we don't have a shape on this one. We got a big number, small number.
I don't feel safe.
I have small number and I have big number. So I'm going to use that kind of weird looking S so we don't get confused with a 5. Okay? Everyone still with me? And I'm using the B. We're not going to try and confuse that with the number 8. Okay? And y'all are looking at it going, dude, I'm not seeing this. Sorry. All right. So Angelo, help me out here. We have a big number and we have a small number. Help me out. What do we know about either of the numbers? What does the problem itself say?
8 times small number. We know it's 28.
Okay. So somehow S and B are going to be put together to give me 28. You agree? Now I don't know if they're add, subtract, multiply, divided. I'm not sure yet. So let's figure it out. Say what we know. What does it say in that first? What does that first sentence say?
8 times a smaller number plus.
So 8S and
Times a smaller number plus 3 times a larger number.
plus 3 times the larger number. So 8 times our smaller number plus 3 times our bigger number. We're going to get a result of 28. Okay. Again, we don't have a shape up here, but this is one of our equations. Now, we still have 2 unknowns. We have small, we have big. We have S, we have B. Okay. There might be a little bit more of a clue that's going to help us a little bit further. What else does it tell us, Angelo, about our numbers?
The second sentence.
Okay. Yeah.
That one says the larger number is twice the smaller number.
The larger number, B, is equal to what?
Twice the smaller number.
So if I double my smaller number, I get the bigger number.
Yeah.
Cool. I like it, Angelo. Breeze. Yo, buddy. Of those green equations up there, are those two different equations? We have 8s plus 3b equals 28. That's 1, right?
Mm-hmm.
And then b equals 2s.
Plus 28. Or,
No, b equals 2s, right?
yes.
So what do you feel I can do with the bottom equation in reference to the top equation? Shh. What do you feel I should do?
I'm not really sure. I'm kind of lost.
Okay,
I don't
well,
know how you got
So I'm gonna. You don't know what? I missed what you said. I'm sorry. Did you follow how we had gotten the 2
No.
just from the sentences? So it told us that 8 times the smaller number plus 3 times the bigger number would sum together or add together to give us 28.
Okay.
And we're using S for small and B for big. I'm just using the letters rather than X and Y.
All right.
And then they also told us that the bigger number is twice the small,
Okay.
right? So now I have 2 different equations. I have the top one, 8s plus 3b equals 28, and then I have the bottom one, which is b equals 2s, right?
Yes.
Okay. So, what would you feel we should do with this? What do you think I should do with this right here in relationship to the top equation?
Would you have to put it in with the 8s?
Yeah, so let's see. I know that b is equal to, oh wait, if b is equal to, well this is b, so I'm going to plug that in. So I have 8s, because nothing happens here, plus what? 3 what?
2s.
2s.
Okay.
So this will all be multiplied, and that now is going to have to equal what?
That's gonna have to equal 6. 6x.
Nope. It's on our top equation. We still know this. We didn't substitute it for that. So I knew that this portion right here is the same thing as what b is. So I took that, plugged it in for b, so this whole top equation stays the same. And I'm just rewriting that top equation. Now we just have s.
Yes.
Okay? So let's do the math. So I have 8 times s, which is 8s, plus, that's 6s, and that's equal to 28. If I add those together, I get 14s. Reese, in your opinion, 14 times what number gives me 28?
Times 2.
Yeah. So my smaller number is equal to 2. My smaller number is equal to 2. My smaller number is equal to 2. If my smaller number is equal to 2, what should my bigger number be equal to?
What is it equal to?
What is it equal to?
2.
No, s is equal to 2. What's b equal to?
Oh,
Huh? 4?
4.
Because I know that 2 times my smaller, well, my smaller is 2, so 2 times that. So my bigger number is 4, my smaller number is 2. Cool. All right, number 5. Gage, we're coming to you, bub.
No, we're not.
No? Please?
Whoa. Come on, Kate.
Dude. We got giggles in back, too. That's awesome. All right. It happens. Clear and ink. Number 5. Gage, number 5. Are we dealing with any shapes on number 5 on page 139?
Are we? Yeah.
What?
No, we're not.
No.
No.
I was pulling it.
I understand. One number is 5 more than another number. One number is 5 more than another number. What's wrong, Mac? Am I destroying you?
No, I'm just tired.
Oh, okay. Did you make it, Stevie? All right. Shh. One number is 4 more than another. 5 times the smaller number plus 3 times the second number is equal to 47. What are the numbers? So I'm going to use S and B, small and big. Because they told us we have a smaller number, and so the one should be larger, right? So I could, what's that?
9 and 4.
9 and 4 is the answer?
Yeah.
Really? 9 and 4?
I got 9 and 4.
Okay, let's test it. Let's see if we can work through it. Okay? One number is 4 more than another number.
It's 5.
One number. Like, not one and a number.
It's 5 more than
number is 5 more. Thank you. I learned how to read well. Guess you need to go back to
Good thing, good reading.
So I did-
Gooder.
I did 5 times 4 is 20.
5 times the smaller numbers, 3 times. Oh, okay.
And then 3 times 9 equals 27.
So if 5 times the smaller number plus 3 times the bigger number is equal to 47, what are the numbers? But they told us that one number is 5 more than the other.
9
So-
is 5 more than 4.
Okay, it is. I agree. But if you talked about one number being 5 more than the other, so one number, so my bigger number is equal to 5 more than the smaller number. Because if I add 5 to something, it's going to be a larger number, correct? So we work through this. 5s, 5s plus 3 times 5 plus s is equal to 47. 5s plus 15 plus 3s equals 47. 8s plus 15 equals 47. Uh-oh. 32. Gage,
Yeah.
I found my smaller number to be 4. I think that's what you found your smaller number to be. And we knew that 5 plus is smaller. So 5 plus 4 is 9. Woo! Yeah, buddy. Love it. Coming to the tired one, Mac.
Yeah.
Okay, wakey, eggs and bakey. All right, dude, John. We're talking about John. My brother-in-law, his name's John.
Wait, you're John. He's John.
You're
John.
5 and 9. Or 4 and 9. 4 and then 9 is bigger. Number 6. Mackie, here we come. John is 6 years older than his brother. You still follow me in this adventure?
Yeah.
His name's John.
I know. But he goes by Mac. TJ, quit staring at him. Weirdo. 3 inches from his face. Hey, it's me. Peekaboo. He will be twice as old as his brother will be 4 years from now. How old is John? So we have John and his brother. Is that okay if I go J and B? John and then brother? Okay. John is 6 years older than his brother. Does that make sense?
Yeah.
Mac, what does that next sentence talk to us about?
Twice as old as his brother will be in 4 years.
Okay, so the brother's B, right?
Yeah.
So John in 4 years will be equal to twice his brother's age. Okay? All right. Mac, does it look like I have 2 equations up there? One of them is J equals 6 plus B, and the other one is J plus 4 equals 2B. Okay. I like it. Let's see. What do we know J is equal to because of our equation?
6 years older than his brother.
So 6 plus B. So what do you think I can do with that in reference to my second equation? Yeah, this can go right in for the J. Okay, so I get 6 plus B plus 4, right?
Yeah.
Is equal to 2B. Okay, so then we combine like terms. That looks like 10 plus B equals 2B. So what does B have to be equal to? I would have subtracted B from both sides, right? 1B. So what is 1B going to be equal to? 10. So the brother happens to be 10. How old's John?
16. Wait.
Why? I heard it. Yeah, he's 6 years older than his brother. His brother happens to be 10, so John happens to be 16. Cool. Deal, guys. Oh, wow. All right, Celine, coming to you. You ready? we got this waitress. She has 52 coins. Still with me? The coins deal with quarters and nickels only. Still with me? So the story goes, waitress empties out the pocket in the apron or whatever, drops it down and says, oh look, I have both, what two types of coins? Quarters and nickels. So, is it easy enough for you to reach in, put a whole bunch of coins on the table to recognize that you have two different types of coin, quarters and nickels?
No.
I think visually.
Problems discerning quarters and nickels.
Okay. So one's bigger than the other. One has rough edges.
Still.
I understand.
Okay.
We'll bring in coins later so we can see the difference between the two. All right. So Celine, number 7. Would it be okay, being we're dealing with quarters and nickels, to go Q and N? Does that make sense? Okay. So waitress reaches in her pocket, puts all the coins down, says, "Oh look, they're all quarters and nickels." Still with me? How many coins does this waitress have? Yeah. So the waitress then had counted up all of the coins, not adding up the value, but just counting them up, and realized there happens to be 52 coins that all happen to be what, Bo? They're both what kind of coins? Quarters and nickels, right? Right? Okay. Shh. A couple of you are talking a little too much. All right. Celine, what else do we know about this? These quarters and nickels. Yeah. So she either went 5 and 25, and combined those together all of the time she could. It came up with how much money? $10.60. So this waitress realized her nickels and quarters were $10.60. And I know that a quarter is worth 0.25. And I know a nickel is 0.05. And what was that little tiny thing I had done to get rid of the decimals? I multiplied, yeah. So I'm not changing the value. If I take this whole equation here, multiply everything by 100, what that's going to do is it's going to move the decimal twice to the right. So I get 25Q plus 5N is equal to 1,060. And then I still know this. I still know I have Q plus N is equal to 52. Now, my feeling, my gut tells me this. I don't have these set up to do substitution. Steve, what sits up there not having them set up for substitution on the green? What classic shows you that they're not set up for substitution? It doesn't matter. I got it on board. In order for substitution to happen, Steve, what do we need to know? What do you think? Shh, TJ, quit giving him a hard time.
Yeah.
TJ's a bully. What do you say?
We should be in
Yeah, I have if it was set up for substitution, I would know Q is equal to something or N is equal to something. But I have Q plus N. I don't have Q equals or N equals, correct? Now, I guess I could move the N over, or I could move the Q over, but this one is set up for us in a certain way. Celine, how would I work this out, how it's set up right now? I want opposite values, okay? So what would you do? Okay. I like it. So, So, Celine said we would get opposite values. She's choosing to get rid of N. So opposite values with N, if I have a positive 5N, what's the opposite of positive 5? Negative 5. So I'm going to take this whole second equation. TJ, what do you got?
Can you write in the
Yeah, right in the clip.
No.
No.
All right. Help me out. Does this equation right here change at all right now? No. But this bottom equation becomes negative 5q minus 5n negative
Something big one.
something big number. So it's negative 10, carry the 1, 25, 260, negative 260. Then I'm going to take this other equation and bring it back down. Steven, if I add those two new blue equations together down at the very bottom, what value is gone? N. So these are opposite values, they're gone. And then so I get 20q, oops, should be 20q is equal to 800. And if I divide both sides by 20, I get 800 over 20 is the same thing as 80 over 2, which is the same thing as 40. So this particular waitress happens to have 40 quarters. 40 quarters plus n equals 52. So how many nickels does this waitress have? 12. So this waitress has 12 nickels, 40 quarters. You have 12 quarters or 40 quarters, 12 nickels. You have $10.60, which gives you 52 total coins. Well, we know that Q is equal to, so I can put it here or to solve the n, or I can solve this n and plug it in here. It's your choice, and it's going to get the same answer regardless. Yeah, baby.
Oh, yeah.
Yeah. All right. All right. I'm feeling pretty good about this, guys and girls. I think. Dude, you really think? Angelo, I would like to say there isn't any, but I think solving system number 9, which is page 141, 142, I think if you did 1 through 7, you'd be pretty solid. So this is word problems day 3, which is page 141, 142, and I'd like you to do 1 through 7. 1 through 7. Okay, and again, guys and girls, they're word problems. Decipher what you know. You're going to start seeing a pattern that when you're plugging values in, you're going to start getting things out. Okay? Today, let's see. Today I have to leave. I have to go to Arapahoe Community College for good stuff for students. No, it's actually not gross. It's really good stuff. Because we are working to get an EMT course for students for the school district. It means you can become a paramedic right out of high school, making $25 an hour. Yeah, so it's not a bad thing. So those are opportunities I'm looking at. Anytime I'm leaving campus, I'm trying to create opportunities for kids.
Yeah, that's good.
Yeah, baby. Everyone good? But tomorrow I should be here for the most part. I have to present to during first, second, and 8th period, just for one class only each of those. So for the most part, tomorrow I'll be in my office. Sound good? All right, guys and girls, you have 10 minutes to get a start on numbers 1 through 7. Please do not waste your time. Let's get a start on it. I'll wander around and help you.